So now let's take a look at the second problem here. Like I said in the first problem, the first thing you should do to figure out which equation to use is try to figure out if there's a temperature change. So reading through this problem, how many joules does it take to melt 35 grams of ice at 0 degrees Celsius? The at 0 degrees Celsius, and then we're also talking about a phase change, is going to give you some hints that there is no temperature change here. At 0 degrees Celsius implies that at the start of the problem it was 0 degrees Celsius, end of the problem it was 0 degrees Celsius. So we can't use the Q equals MC delta T. So now we're going to use the Q equals MHF or MHV. So you have to figure out if it is Q equals MHF or MHV. And then remember the rules for phase changes here. So for phase changes, you're using either one of these equations, but you have to figure out which one to use. So for a solid to a liquid or a liquid to a solid, you're talking about the heat of fusion here. So heat of fusion, so you'd use Q equals MHF. So I'll go ahead and write out the formula. And now start listing the variables. These problems are actually easier because there are fewer variables. So we have Q, we have M, and then we have HF. So you're going to get HF from the reference table, and you're going to get that front page of the reference table, 334, and then you're going to get the mass from the problem, 35 grams, and you're solving for Q. That's going to be X. So after you've done this, you're going to start plugging numbers into the formula. So Q is still going to be a variable. You could write it as X if you like, or you could write it as Q. Q is equal to M, which is 35, times HF, which is 334. And that's it in terms of variables going into it. So you plug this into the calculator, and it's just 35 times 334, and that's going to give you a large number here, which is going to be 11,690. And once again, you're calculating joules here, so you make sure you include the unit there. So going down to the third problem here, how many joules of heat are given off when 85 grams of steam condensed to liquid water? So the first question you ask yourself once again, do we have a temperature change? Temperature is not mentioned anywhere in that problem, so we don't have a temperature change. So you're going to have to use HF or HV again. You cannot use Q equals MC delta T. So here, we're talking about phase change involving gases. So we have 85 grams of steam, gas condensing to liquid. So whenever we have gas involved, you're using the heat of vaporization. So go ahead and write the formula, Q equals MHV, and start listing the variables, Q, M, HV, and start listing. So Q, you're calculating. That's going to be X. The mass you're getting off the problem, 85 grams. And then HV, you're looking up in the very front of the reference table, the same table that you got the specific heat of water and the HF value. And that is 2260. So now you start plugging things in. So once again, you're only plugging things into the formulas after you have written the formula with no numbers in, and you've listed the variables here. It may seem like it'll take more time, but it's going to ensure you get the right answer. So now we start plugging in variables in. So we get Q is equal to M, 85 grams, times HV, 2260. Plug that into the calculator. And we get an even bigger number, 192,100 joules.